Okay, so let's start with formula number 4 on your purple sheet. Number 4 is the molarity formula, and it is the most important way that we measure concentration in chemistry. Where will you use this other than in chemistry? Probably nowhere. But that's okay. This is what we use. So every time you see a solution on the table here, and it has like a concentration here with a unit, it's always big M, because that's how we measure concentration in the lab. The formula itself is pretty simple. Moles solute divided by liters of solution. You're not multiplying by 100 because it's not a percent. Ladies, I'm going to move you. It's not a percent, so this time no times 100. The only thing that's like kind of goofy about the molarity formula is that not always do you know these things. Can you hit the door? So sometimes you're given not moles but grams. If you're given grams in your problem, you may not use that number in the formula because the formula is asking you for number of moles. So if you are given grams, you must convert grams to moles. You know how to do this. Do you remember how? Yes, but it's even more basic than that. You're going to divide by something. The formula weight. So I would make a note of that on my purple sheet. I would say that of the mistakes that people make, it's just using the straight up number of grams and not converting it to moles. So you have to really be careful. You can't be a lazy chemist when you're doing your homework or solving these problems or when you get to a test because you cannot assume that the number I'm giving you is the number that you need. The reason I do this and make you go through this process is because this is one of the most basic things that we do in chemistry. I was actually just thinking about the one and only time I crashed out when I taught at Silver Lake College was because I had students who were in their 5th college semester with me as their chemistry professor. And one girl in the meanest way possible was like, well, we don't know how to do that, like this thing. You guys know how to do this. It was her 5th college semester with me. And I crashed out and I discovered that if you hit a whiteboard hard enough with one of those dry erase markers, it'll explode. So it's an important thing to know how to do, and you're always going to need to know how to do it.
College?
Yeah, I taught at Silver Lake College for 11 years. Also, sometimes you're not given liters. Sometimes you're given, and like really a lot of the times, if you are given not liters but milliliters, you have to do another conversion as well. So to convert between milliliters and liters, unless you're Duco, who can do this in his mind, you are going to have to remember that you need to divide by, not the formula weight here, but by 1,000. Duco can do this in his mind because he is from Europe, and they know how to use the metric system there, and we do not. Sorry for calling you out, Duco. So make note of these things because you have to be very careful about all of the details that are in your problems. Okay, so now that we know how to use, you probably want the algebra for the different form, like solving for the different things. Is that true? You maybe want that? Shoot. Why is it drawing and not moving? How do I do that? Is it okay if I move this? Everybody copy this now? We're just going to get rid of it. Okay. So Molarity formula is the one that's on your sheet already. Moles solute divided by liters of solution. If you want to solve for the moles of your solute, you'll use this formula. You'll just multiply big M times liters of solution. It has to be in liters though. So if you're given a milliliters, you've got to convert it. And then if you want liters of solution, you'll take your moles of solute divided by the molarity, which is big M. It's really important that your M's look like capital M's because there's another unit of concentration that's not on your purple sheet that's abbreviated little m, and it's not the same. So it is case specific. I was just correcting some homeworks, and I noticed that sometimes people, or I think it was a lab I was maybe correcting, and somebody was trying to write silver, and they wrote this. I don't know where you guys are picking up this bad habit, but I marked it wrong. The second letter of all of the element symbols is a lowercase. So, unless you want me to bring back the element quiz, you got to be careful about. You got to be careful about the capital letters. Okay, so now that we know this and we have the algebra, let's do an example problem. Number 6? Okay.
Why number 6? What's the next one I have to do?
Okay, let's do that one. Ask and you shall receive, Hunter. All right, my friends, if you do not make a data table, you are going to be cooked. So make your data table. Okay, so it says in my problem, how many moles of NaCl are present in 100 milliliters of 0.125 molar solution. Okay, so mole solute is my question mark. How do I know that? It says how many moles. So whenever it says how many or calculate the, that's your question mark. And then it says moles of NaCl. And remember, if you see of a compound's formula, that's how you know it's the solute. I can write that back on the board for you, but you should have this written on your purple sheet. If you see the words of solution, you have the solution. If you see the words of water, you have the solvent. And if you see of something and it's a name or a formula, I can't write today. That's your solute. And so in my problem, I see that it says of NaCl. So that's how I know that it's moles of solute. So how many moles of NaCl are present in 100 milliliters Careful with that decimal point because that's determining our significant figures. And then it says that of solution. So that must be the volume of my solution. And then we're given another number, 0.125 m. And if it's big M, then that's your variable. Okay, so there's only one problem. Well, okay, so what formula should we use? Let's write that down first. What formula should we use? Mason?
Mole solute equals molarity times liters of solution.
Perfect. M times L. Okay. So now I'm going to put so I got this from my purple sheet, and now I'm going to put my values, my numbers, into this formula.
Don't we have to switch the mode?
Just wait. You're ahead of me, Kaden. Okay, so now I plugged in my M in my data table into my formula. And now, Kaden, you are absolutely right. He said, don't we have to switch the milliliters to liters? Yes, we do. And here, I should, like if I didn't do it originally in my data table, that's fine. But by the time I get to here, it's asking me for liters of solution, and that's not what I have here. So to go from milliliters to liters, you're going to divide by 1,000. So your number should get smaller, because a liter is a big unit and a milliliter is a small one. And so that's the number that should go into my formula now. I can do this math, and I'll get 0.0125 as my number. Ask yourself the two questions. How many significant figures should I have? How many should you have?
3.
3. And how many do you have? So we're good. And then what should be your unit?
Moles and HP. Or just mole.
Yeah, either one is totally fine. And that's your answer. Now, if you didn't know what your unit was, where could you find that information? If you go back to your data table, just look at what you wrote as question mark. That will tell you what your unit should be. How did this go? Was it easy or hard? Easy? Easy? Medium? Let's do another one. Let's do number 7. 7 is an example of why we need a data table and why we need to read a question carefully. Mason?
Just the unit formularity is just the capital M.
Capital M, yes. Okay, so number 7 asks, how many grams of glucose are present in 1.50 liters of solution? So liters solution then equals 1.50. And then we're given a number with an M at the end, so that must be the M. Okay, so this is 40% of your grade is making this list. The next 20% of your grade is choosing the right formula to use. So now this is where things get a little bit tricky. There is no formula that has all 3 of these things in it. But because we're given the concentration, we should know that molarity is something that we should look at. Okay, so how did I know to do this? Well, I'm given a capital M, so I'm going to have to use this formula at some point. All right, so which one of the 3 variables in this formula do you not know?
Mole.
You don't know mole. So let's solve for mole. If you are okay with algebra, this is what you'll get. Otherwise, it's the same one we just used. Big M times liters of solution. Okay, so we've got all the necessary things to solve for moles. Let's do that. Our molarity is 0.400 big M. And then do we need to do any converting for the volume here? No, we do not. Okay, so then if you do this math, what does your calculator give you? Good. All right. How many significant figures should you have?
3.
How many do we have?
1.
Okay, so we got to just slap 2 zeros there at the end. What's our unit? Grams is what we're looking for, but what did we get from doing this work here? We got mole. Okay, so that means that we don't have what we're actually looking for in our problem. How do we go from moles to grams?
Divide by the formula weight.
That's how we go from grams to moles.
Oh, times by the formula weight.
Good. So if you're going from grams to moles, you'll divide by the formula weight, and if you're going in the other direction, you'll do the other thing. You'll multiply by formula weight. Okay, so so I guess you do need your periodic tables today. Sorry, Elliot. I lied to you. What's our formula? Is it glucose? Okay. C6, so 12.01 times 6 plus H12, so 12 times 1.01 plus O6, 6 times 16. So I'm going to multiply, my formula weight is 180.18 grams per mole. And so I'm just going to multiply that number by 0.6. And this is what my calculator gives me. Okay, so how many significant figures should I have here?
3,
And how many do I have?
6.
Yep, so I'm just going to put a line here. Otherwise, you can round. 108 is totally fine. What's my unit, though, now?
Grams.
Good. This is as complicated of a problem as you'll see. But all of this, now that you know how to use molarity, the rest of it is chemistry you already know. Like this part here, we already knew what to do here. So, ouch, that should be more of a review. Okay, so now that we've got molarity pretty good, let's talk about formula number 5, the dilution formula. So when I buy chemicals from the chemical store, you can buy chemicals in the concentrations that you need them, but it's pretty expensive to do that, especially since you might not know what kind of concentration of stuff you need. And so if you know how to use the dilution formula, you can buy one big container of a concentrate and then just dilute it until it runs out. And so it's just like the cost-effective way of doing things. You can buy all of the different concentrations, but it's expensive for something that's just a convenience. The dilution formula looks almost like exactly like the titration formula. And so I suppose I should solve it for you. Here's your algebra. This is nothing new. We've already used something almost identical to this. The only thing that's tricky with the dilution formula is that it's a little bit more difficult to choose what is M1 and V1 versus before, like when we were using Na and Va, you could always look for the compound, and if you knew if it was an acid or a base, you would know which N or which V you had. This is a little bit trickier. So the important thing that I want you to write, like maybe on your purple sheet, like this is what you have to remember. If you see the words of a, that means that you've got two bits of information about the same solution. So, how do I write this? Of a keeps the data together, I guess. Or in other words, if whatever number is on the front and the end of this phrase will be your M1 and V1. Or your M2 and V2. Doesn't matter how you identify them. And some of you will identify things differently than I do. That's okay. As long as you keep the things together that are meant to be together. And that's where that of a will be important. Okay, so let's do an example of this from your homework. Let's do number 10. I'm going to leave this here in case you're still copying it. And I'm going to do number 10 on the board. Okay, so I'm going to read my problem. What is the molarity of 50 milliliters of a 0.5 molar NaOH solution after it has been diluted to 300 milliliters? Okay, so if you see that word diluted in your problem, that's a dead giveaway that you have to use the dilution formula because the word's in the sentence. So if I know that I'm using the dilution formula, I can make my little list here of all of the things that it requires. Okay, so my first number in this problem is 50.0 milliliters. Is milliliters an M or a V? It's a V, good. Okay, so since it's the first number that I see, how about we call that V1? And did you have a question?
No.
Okay.
I'll say.
Okay, so then do you see where the next words after the 50 say of a?
Yep.
That next number then has to be M1. Because of a keeps those two bits of information together. So we've got a V, the 50, and an M. How did I know it was an M? Because it says 0.50 M. And then the other piece of information, or like math, I guess, that we're given is 300 milliliters. Is that V2 or M2?
V2.
Good. And we know because it's milliliters. So then what must be my question mark?
M2.
M2. Okay, so then choose the formula that solves for M2 and solve for M2. Divided by 300. I lost my calculator. Where did it actually go? Oh. Special. Okay, did you get 0.08333333?
Yeah.
I'm just going to write one of them. How many significant figures should I have? And so now I have 2 significant figures. That's good. What's my unit? Good. The only thing tricky about these problems is the of a. Like you just have to lock into where those are. Number 11 is a trick question. Number 11 says, if 300 milliliters of water is added. So the problem tells you what you have to do. I don't know. So what do you do when you're adding water? You're diluting. Okay, good. So dilution formula See if you can identify all of your variables without me.
Alright.
What's for lunch today?
Loaded mac and cheese.
Okay. On Monday, Mr. Miller brought in these treats because it was his birthday over the weekend. And it was the best like school lunch I've ever had in my life. He made baked potatoes, but then he, like, before he baked them, he like rubbed olive oil and seasoning and salt on the outside, and they were really yummy. And then he made these, like, do you know what a manicotti noodle is?
Yeah.
There's like a big noodle that you stuff. He stuffed these noodles with this like jalapeno popper mixture, like filling, and then wrapped them in bacon, and then brown sugar and like barbecue sauce, and smoked them, and they were the most delicious thing I'd ever eaten in my life. I mean, he could be like a chef at some place.
They were good.
He's amazing. I don't know, like, I'm such an unclever person. I would never come up with this stuff. It's like he just made that up. But, like, that was his made up thing. All right, so what did we identify as M1?
Question mark.
Question mark. Okay, good. What did we identify as V1? 300. What did we identify as M2? As 500?
Point.
0.500, okay.
I had these.
I was gonna say. And then V2 is...
200. Wait, Miss Bishop, is it okay that I had like the M2 and the M1 switch?
As long as you keep the volumes with, like, where they're...
Yeah.
With
I
what
just
they're... Yeah,
put like 0.500 as M1 instead of M2.
that's totally fine.
Okay.
Okay, so there's one thing that's wrong here. The one thing that's wrong is the V1. We gotta go back and read our problem. It says that 300 milliliters of water was added to the 200. So how much do you have then at the end, actually? 500. So V1 isn't 300, it's 500.
Oh no.
That's the trick question.
Why does it do that?
I just threw it in there just to see if you were paying attention or not.
Yes.
And so for those of you who are paying attention to me right now, you'll get this question right. Those of you who are not paying attention to me right now, you're cooked.
Good thing I was paying attention.
Good thing. Okay, so now everything is normal. We're going to solve for M1. So we're going to use, unless Kaden, you have it as M2, which is totally fine. You'll get the same answer. As long as your numbers here are in the right places.
Yeah. All those numbers are fine.
And then divided by 500. What do you get for an answer?
Yeah.
Do you get 0.2?
Yep.
How many significant figures should you have? What's your unit? Good job. Uh-oh, we're at 29 minutes. I told you I was only going to talk for 30, and so we're going to leave number 6 for next time. Then I'll have a little teaching to do.
I did number 6.
We did not. Oh, I mean formula number 6, Keaton, I'm sorry.
Oh, okay.
So if you come across the word normality or big N in any of the problems, I think they're mostly on like pages 5 and 6. Those ones you still don't know how to do. The rest of them you do know how to do. Make sure you have 0.200, Donovan, because you need the 3 sig figs. Let me know what questions you have.